So I'd like to move the discussion also on PT system upgrades and the role of software within the upgrades. And since the introduction of particle therapy, PT systems have gone through a number of changes from one generation to the other. Typically, existing, that means a running PT machine, rarely goes through an upgrade stage, especially due to the high costs of downtime, right? What role does the software play in a PT system upgrade, and how does it impact an optimal design for upgrades? Jay, what do you say about this? As a technical director, you have been involved practically in the whole life cycle of the machine in the birth center, right?
Yeah, and we don't have enough hours to really discuss that topic. That's like half of my life devoted to that topic. On the other hand, now, you think about it, we now have about 110 particle therapy facilities in the world. And most of the world has sort of evolved into the scanning modality. So unless things like flash and microbeams become even hotter, a lot of the change that we've experienced might be slowing down. I'm not so sure, but it might be. We've certainly evolved beyond the infancy stage in terms of system capabilities. And although there's always a reason to replace a LINAC every 10 years, I'm not so sure that's the same with a particle therapy system. But there will be more improvements, like better real-time imaging, particle-based imaging, for example, and adaptive therapy. So let me come back to that in a second. These things should happen on the base of what exists. And some people might say intrinsically that's not possible. I say it should have been possible. And that's the rub. Because of the integration issues that we've already discussed, because of the way the systems have been architected and specified, we're not there yet. If that beige paper that I wrote had been treated more seriously, I think things would have been different now. Take a patient positioner as an example. It has 6 numbers that are needed to be exchanged. And except for collision issues, that is all. And I just have to repeat it. That is all. Yet in some systems, it's an act of heaven to enable a replacement of that kind of a system with downtime and all that. You should be able to pull it out in the weekend, put in the new one, hook up those 6 wires, and that's it. But the systems are not built to do that, even though it's possible to do that. Or a process, for example, like scattering, is so tightly woven into the software that making it necessary to completely replace entire subsystems to upgrade to scanning. I developed this concept called treatment point concept, making the concepts of the room, modality, delivery, all generic, so that it was just a question of upgrading the hardware and not so much the software. But it wasn't really accepted. But I guess change is a question of vision. It's only considered change if it wasn't originally envisioned. So in fact, in all these upgrades, software has always been blamed for the most difficult part to upgrade. And how much of this was due to the fact that software engineers never stay in the same place too long, and therefore the system knowledge is lacking by the people when it's time to do the upgrade, or that's something else. That's why this is a much longer conversation. But with a properly architected system, a properly modular system, and a properly thought through system, it wouldn't be such an issue to upgrade. And maybe that's discussion happening later, but that's when outsourcing might become important.
Thank you, Jay. Zhongfeng, do you have an opinion on this from a clinical user perspective?
Yeah, that was a very interesting question. That's something that, frankly, I do wish that the vendors could have done better. As Jay mentioned, the system software, many of them were designed from the beginning not with future upgrade in mind. Therefore, the system were not really modularized enough. I mean, that's impact particle therapy even more, because I have several treatment rooms. And if I'm just upgrading one room at a time, I cannot do that, because the entire system need to be done. It needs to be done to be put into a testing mode to to allow you to upgrade to something that does impact the entire system, but the rooms were not separated enough to allow me to treat patients in other rooms while the upgrade is going on in one room. I mean, that part that can never be done separate anyway, right? I mean, you cannot upgrade a cyclotron without impacting all the rooms together. I mean, I accept that. But I just wish that we have all spent more time, the vendor side, especially software designer side, to modularize the things, to kind of put them into their own little cubby holes, so that you can plug, maybe not plug and play, but at least have a little bit less damage on the entire operation. I mean, there are vendors that would refuse to provide any upgrade support. You basically cannot upgrade anything at all, just because the software design, I think it's more software, because some of the upgrades were just totally localized to one room, just like Jay mentioned, upgrading the patient position in one room, or install CBCT in one room. You cannot do it. I mean, I can't believe it. It just hurts there will be future upgrades coming in, and there's no question in my mind that we will see future upgrades for any particle system. I mean, it's a system with 25 or 30 years of life expectancy. There's no way you can get away from that. I mean, by 30 years from now, maybe Microsoft wouldn't exist anymore. What do you do then? Or Linux, maybe bought over by some company, you cannot use it anymore. Who knows? I think everybody want us need to keep that in mind. And the first consideration, of course, remains safety. But I would like to have the clinical impact of a non-operating system for an extended length of time. I mean, we look at upgrade. If our entire system was down for 3 months, effectively will be down for 1 year, because it takes time to ramp down the patient and takes time to get the patient back. And by that time, the center is closed already. I mean, you're bankrupt. I think it's significantly important. There's no question about it, and everyone really need to be have some good thought about it.
Thank you, Zhofeng. Rock, from the manufacturer's point of view, what are the factors which impact the PT system upgrades, in your opinion?
Well, I mean, I'll talk about radiotherapy systems in general again here, and fundamentally, you should not upgrade everything at once. I'm a firm believer in having good divisions between systems. So, for example, in the case of proton radiation therapy, the beam delivery, the beam steering, everything that gets the beam out of the nozzle is separable from everything that positions the patient, from verifies where the patient is. And so those two systems should be fundamentally separable. And of course, you need a model of one, but you could replace the patient with an orange crate and a phantom, and the beam should still be delivering in exactly the same way as if there was a patient there. And then the patient should be moved around and imaged independently of whether it's a proton beam or a radiotherapy beam. So there's a nice separability possible there. So splitting it into functional things like that. So of course, the verification of where the patient is also used to verify where the beam is. So those two systems should probably be upgraded in two times, because the older system can help verify the newer system. For example, in tomotherapy, we introduced a beam checking system. We had a detector that was used for megavoltage CT, but it intercepted the megavoltage beam, and that was extremely useful for verifying where the beam was. So we took to not upgrading the control system of the accelerator and the verification system of the accelerator at the same time. Because in one case, you want the verification system to be in the state where it can detect any small changes in the beam that you've just implemented, and vice versa. You want any upgrade of a checking system to give you the same results if the beam is unchanged. So just clever ways of upgrading a system. I also believe you shouldn't upgrade
treatment planning system and a radiotherapy system at the same time. They're separable, and one helps the other verify the other. So simple things like that. It's good, obviously, to have very close coordination between software suppliers, or ideally have the same software supplier that understands the whole system. So having one partner, Leo Cancer Care, which I founded a couple of years ago, is partnering with Cozy Lab because of its broad knowledge of proton radiation therapy. And the entire proton radiation therapy treatment workflow, from treatment planning through to accelerator control, on to record and verify, and so on.